So these are 6a notes continued. If the index of our radical is even, such as this one, which doesn't have anything, so that's an understood 2 right there, a fourth root or a sixth root, eighth root, 10th root, and so on, the radicand is negative, so the radicand is the number on the inside of the radical. There is not a real root. So, for example, fourth root of negative 16 is not real. So not only is that true for square roots, it's true for fourth roots and sixth roots as well. We saw it with the fourth root of negative 1 in the last video. However, if the index is odd, so if it's a third root or a fifth root or a seventh root, there is always a root for it. All right, so let's look at this. Simplify each radical expression using the order of operations. So I'm going to work on the inside of this radical. And I'm going to square negative 3 and get square root of 9. And the square root of 9 we know is 3 because this symbol means the positive answer. The square root of 5 squared would be the square root of 25. So I'm going to square this first, get 25, but then we know the square root of 25 is 5. So what we want to notice is that this was no surprise that the square root of 5 squared was 5, but the square root of a negative 3 squared ended up being a positive 3 because when we squared it became positive, took the square root and it was going to be positive. So what can we conclude about the square root of a squared? Doesn't matter if it's positive or if it's negative, the square root of a squared is always positive. So when we take the square root of a number, we want the positive or root, which is the principal. I think I probably reversed those two words. Principal root. You get the idea though. So we want the positive or principal root. So think about the square root of a squared is equal to a. So we say that, but we don't really know what a is, do we? It could stand for 1/2. It could stand for a positive 30, it could stand for a negative 3, it could stand for anything. So if we do not know if a is positive or negative, what can we do to make sure that it is positive? What's going to force it to be positive? Well, we're going to put the absolute value bars around it. So absolute value. So how are we going to write the square root of x squared? We're going to call it, because we want to force it to be positive, and we don't know if it is or not, absolute value of x. The square root of d squared, we can't just say that it's d because we don't know if it's positive or negative, so to force it, we make our absolute value bars. So if n is an even positive integer, so it doesn't matter if it's a square root, so the square root of a squared, the fourth root is a to the fourth, the sixth root of a to the sixth, we have to use absolute value bars because they all have both a positive root and a negative root. So we don't know. So we're going to force that and make that be positive. And then if n is an odd positive integer, so if I'm doing the cube root of a to the third or the fifth root of a to the fifth, seventh root of a to the seventh, the answer is just a with no absolute value bars because we know like the cube root of negative 27, which is negative 3 cubed, is negative 3. So we will have negative answers when we're working with cube roots and fifth roots and seventh roots. Let's work a few problems here. So here I have the fourth root of negative 2 to the fourth. So this is even, and so I want my answer to be positive. And I'm going to have to use, well, yeah, I'd use my absolute value bar. So the absolute value of negative 2 is positive 2. Then the fifth root, if it's odd, then the fifth root of negative 2 to the fifth is just negative 2. And the sixth root, again, now it's even. The sixth root of negative 2 to the sixth is going to end up being the absolute value of negative 2, absolute value, which is 2. So even roots can only have positive answers. odd roots can have a negative answer. 18, the cube root of x plus 7 to the third is just x plus 7. So these are just kind of fancy ways of doing what we had on this page. The nth root of a to the nth is a. So that's what we're doing. In this case, it was the cube root of x plus 7 to the third is x plus 7. This one, 16, is 2 to the fourth. So we got 2 to the fourth and m to the fourth that we're taking the fourth root of. So the fourth root of 2 to the fourth is 2. And the fourth root of m to the fourth is m. Now 2 I know is positive, but I don't know about m, so I've got to put my absolute value bars around it. So remember, with even roots, variables need those absolute value bars. And then 20 is a fifth root. So remember, we memorized the fifth root of 32 is 2, and the fifth root of p to the fifth is p. And because this is an odd, I can have a negative answer for it. So it's going to be just 2p. 21, the sixth root of negative 64. Even roots, I cannot take the square root of a negative number. So this one is not real. So the sixth root of positive 64 is 2. But if I multiplied a negative 2 times a negative 2, did that 6 times, I'm going to get a positive answer, not negative. So I can't find one for the sixth root of negative 64. The eighth root of x minus 2 to the eighth is going to be x minus 2. Do I put an absolute value bar? You're right. This is an 8, which is even. So I need the absolute value bars around that. And finally, number 23, now here's our happy little family. They're holding hands. We need to have this written as a power. So if I were to factor this, it would factor into x minus 3 times x minus 3, which is x minus 3 squared. So this is actually the square root of x minus 3 to the second power. So the square root of x minus 3 to the second power is x minus 3. And I need, yes, I do, an absolute value bar because these are evens. And that's the end. See you next class.